Welcome to the Mechanics 1 video as an introduction to vectors. Today we're going to talk about using I and J notation for vectors. We're going to understand the term position vector, and we're going to talk about finding magnitude and direction of a vector. So to start, we need to talk about what unit vectors are. So the unit vector I looks like that, and the unit vector J looks like that. So these small vectors that are 1 unit in length, hence the name. I is the vector 1, 0, so 1 unit to the right, and J is the vector 0, 1, 1 unit up. Any other vector can be expressed in terms of I and J. So if we just do a quick example, so the vector here represented by the red arrow. So we just consider what's happening with that. So that vector is 2 across and 3 up. Moving 2 to the right, which would be 2i, 3 up, which would be 3j. So we can consider this vector as 2i plus 3j. Moving on to talk about position vectors. So a position vector tells you where an object is in relation to the origin. The origin is the point 0, 0. So if we use that to deal with a simple problem, an object starting is measured with a position vector of 4i minus 2j, and it ends with a position vector of minus I plus 3j. If we consider trying to find the displacement of this motion, so 4i minus 2j would be 4 to the right and 2 down. And it ends with a position vector of minus I 3j, which would be minus 1 to the side. So we're essentially using vectors as an alternative to dealing with coordinates. If we want to find the displacement, so we started with the position down here at 4i minus 2j position vector, and finished with the position of minus I 3j, so we're travelling from the position down here up to the alternative position up there. So that's the vector that we need to describe. So if we consider this as a triangle, so we've moved a distance of 5 to the left, so that would actually be minus 5i, and we've moved a distance of 5 up, would be positive 5j. So the displacement for the whole journey would do with minus 5i plus 5j. The final thing we were planning to discuss was magnitude and direction of vectors. So to start with, we're going to consider drawing out a triangle to represent the vector. So our vector xy has an x horizontal value and a y vertical. We're going to use the Pythagoras theorem to find the magnitude of the vector. So we do the square root of x squared plus y squared. And we can use trigonometry to find a desired angle. So our angle would be tan to the minus 1 of y over x. That would give us the angle being marked on in the diagram there. So if we try that for an actual vector, so here we've got the red arrow, and we're going to try and find the magnitude and direction of the red arrow. So if we consider making this into a triangle, and we've got this horizontal amount of 2 units, and vertically we've got 4 units. So if we want to find the magnitude, that's going to be the square root of 2 squared plus 4 squared. So 2 squared is 4, 4 squared is 16. So that's coming out being root 20. In core maths, we leave that as root 20, but in mechanics we usually turn that to a decimal value. So root 20 to 3 secant figures is 4.47. If we consider working out the direction as well, so we need to work out an angle. So let's say we'll calculate the angle in here. So we can calculate the angle by doing tan to the minus 1 of the opposite, so in this case that would be 4 over adjacent, which would be 2. So again, if we calculate that, tan to the minus 1 of 4 over 2, which is just 2, gives us a value of 63.4 degrees. Okay, so that concludes our introduction to vectors.